6.5 Quadratic Formula. All your directions for this section are going to say to solve. In the book you'll see a few other directions, and we'll talk about those as we go through the lesson here. I'll write those out for you. But because it says solve, and you just had a section on solving, let's make an attempt to do it the way we know how. And so far, that's factoring. Now, I'm using the x. If you use the other method, you can give it a try. The outcome is the same. If I take 2 and -5, I get -10, 4 on the bottom. I can use the t-chart kind of with it here and try to come up with two factors. Well, I know they both have to be negative to add up and make a positive. So -10 and -1, no way that's going to work. 5 and 2, both negative, no way that's going to work. And I think we've covered them all. So factoring, it's not going to work. Put a big X through it. We can't factor this thing. So what we're going to have to do is come up with another approach. So let me come out and write it one more time here for you. 2x squared plus 4x minus 5 equals 0. Again, we're trying to solve this, but we just figured out that factoring doesn't work. Turns out that a lot of times in the real world, factoring doesn't work for you. It works on nice, neat problems. Most things in the real world have some pretty bizarre-looking answers. So this lets you deal with everything else, anything that can't be factored. If I give you an option, you want to try to factor first, because it's going to be easier. But if you can't, this is your fallback. This will work for everything. So you can always use quadratic formula no matter what. But here's how it's going to go down. The formula, actually I'll come on back here, just slide on down the page a little bit, is -b plus or minus square root b squared minus 4 times a times c all over 2a. And actually I need one more thing here. X equals that. Just like before we were solving for x, these are the things x will equal. Looks really crazy, I know. Where you're getting your a, b, and c is from ax squared bx plus c equals 0, a trinomial. The coefficients in your trinomial are the pieces you plug in here. Looks really crazy. It's going to take you a little while to get used to it, I know. It's kind of tedious, has a lot of parts, but you do have to memorize it. That's where a lot of students go wrong. Make sure you memorize this. You can sing it to Pop Goes the Weasel. You can ask me to do that in class. Maybe I'll give it a shot. But make sure you're memorizing this formula. Looks like a lot of parts. I think the best way to memorize it is just keep doing problems. The more problems you do, the more you'll get familiar with it. And I would recommend that instead of just watching, or instead of just trying to look at this and memorize every symbol. I think by doing problems, you'll memorize it through doing the practice. So we'll keep the formula kind of handy. We'll go back to that first example. We'll give it a try. First thing you need to do, identify A, B, and C. If you're going to plug into the formula, we need to know that A is 2, B is 4, C is -5. Make sure you put that negative there. The first thing with x squared, B is the thing that goes with x, and C is a constant that's by itself. And that's how we get A, B, and C. All right. So -b, well, that would be a -4 because B was +4, plus or minus the square root of B squared, which again was 4, minus 4 times A times C, all over top of 2 times A. Okay. And it's a lot of pieces. We do have to follow order of operations, so all the rules we know will keep coming up. And this will look a lot like some stuff you did in Chapter 5 with square roots. And that's why we did all that stuff. Remember I told you that you would use it later? Well, we're working toward an application here. So we're getting closer to be able to use it for the real world. Now, first thing you want to look at is inside of the square root. Parentheses first, and brackets of any sort, including square roots, work like parentheses. So inside the bracket, we can really do nothing to things that are inside parentheses, but we have an exponent, so we'll try that first. So negative 4 stays, plus or minus square root, just copying it down. The only thing I can really do at this point is square 4 and get 16. All right? So 4 times 2 times negative 5, all over 2 times 2. And I'm going to go ahead and make 16 stand out a little bit here because that's the one thing I changed. All right. You're probably going to find it easier to work across the page. I'm going to probably run out of room, but we'll deal with it. But that seems to be the easiest thing to do. Go across the page. All right. Inside the square root bracket, we've got some multiplication to do. So again, copy the negative 4, copy the plus or minus. This time, copy the 16. A lot of copying. Negative 4 times 2 would be negative 8. Times negative 5 would be positive 40. And still over 2 times 2. Okay? So let me highlight that 40, just so you recognize that is the thing I changed. That's what I did different in this step. Okay? Almost done with what we can do inside the bracket here. Copy negative 4 plus or minus. 16 plus 40 is 56. And that's over 2 times 2. Okay? All right, I'm going to draw a big arrow, come back over here, and bring my work back to this side. All right, so now I need to go ahead and multiply the things on the bottom. And if I could, combine things on top. So I think I'm going to go ahead and just copy what's on top right now, and then multiply the 2 and 2 together, make 4 on the bottom. Now, what you don't want to do is see that you have a 4 and a 4 and cross them out. It's not allowed. In order to divide a number out of the top, you're going to have it be a factor of both terms. This is a binomial. It's kind of a weird binomial because it's plus and minus, but it's a binomial. So 4 has to come out of both the 4 and the square root of 56 before we can actually divide that 4 out. Very tempting, but don't do it. You'll be wrong, and then problem's over. So we do know how to reduce radicals. Let's give that a shot. So somewhere on scratch paper off to the side, I'm going to take 56, break it down. Okay, use your factor trees. 8 and 7 work. 8's a few 2's. Well, that gives us a pair of 2's and a 2 times a 7 left over. So back up here, negative 4 stays, plus or minus stays. Square root of 56 becomes 2 times the square root of 2 times 7, or 14, and still over top of 4. Okay. Well, now that 4, again, don't cross it out. It can't be done that way. We do have a common factor, though. 4 and 2 can both be divided by 2. So here's the way you want to deal with this. If I took a 2 out front, if I factor out a 2, okay, factoring all that stuff from chapter 5 is going to keep coming up. All right, so that's negative 2. That would make our negative 4. Plus or minus, that would be 1 times the square root of 14. Okay, because if I multiply that back out, I'm right back here. It's factored. Okay, still 4 on the bottom. Now that you have a common factor you've taken out of both terms, now you can reduce, and that would become 1 over 2. All right, so we're just about done. We have negative 2 plus or minus the square root of 14, all over top of 2. And it's tempting to cross those 2's out, but you can't do that either. You don't have a 2 in front of the 14 right now, so you can't cross them out. That is probably done for me. If you're trying to understand what this means, it means 2 things. Negative 2 plus the square root of 14 over 2. And it also means that negative 2 minus the square root of 14 over 2 means both of those are solutions. What I'm going to recommend is you just leave it with the plus or minus. That's good enough. And how this translates into what we're doing, we're going to put this on a graph again. And I'm not going to guarantee this is what your graph looks like, but it's something like this. It's a parabola. It crosses the x-axis twice. And these are the 2 places where it crosses. Okay. Again, we're going to graph soon, but not quite yet. So that's where it's heading. These are irrational solutions. That means they're decimals that never repeat or never end. So a lot of steps. Just be very careful with all your work. And the easiest thing to do is make one little mistake and it ruins everything. So be very careful doing all your calculations here. All right, so that had two answers, and here they are. So take a look at that, pause if you need to, watch it a couple times. I know it's a lot to keep track of, but the work itself is not too bad. All right, on to another example. Let's do the same process again. This time, again, you could try to factor. This one will work by factoring, but I want to show you how to do it with quadratic formula. Okay, so A is 4, B is -20, C is 25. Okay, that's our three coefficients here. So negative B, in this case, I'll tell you what, I'll write the formula out just so you can see it all again. All right, negative B would be positive 20 in this case, because a negative 20 would be positive 20. Plus or minus 20 squared minus 4 times A, which is 4, times C, which is 25, all over top of 2 times 4. Now I'm going to work this one out a little bit quicker. We didn't have to stick to order of operations so strictly as we did that time, and I just wanted to be very clear on what each step was doing. So here, what I'll do is go ahead and square 20. That's going to be 400. You're going to get some big numbers. It happens. It's not too bad to deal with. We can multiply these together. 4 times 4, well, negative 4 times 4 is negative 16, times 25 is actually 400. Maybe a quicker way to do that is, 4 quarters is $1, so 25 times 4 is 100, and times another 4 would make it negative 400. Okay, probably see something getting ready to happen there. 2 times 4 is 8. Okay, so 20 plus or minus square root of nothing, which is nothing, over 8. So we're just about done here. That means it's 20 over 8. That's it. The plus or minus part disappeared. Plus or minus doesn't matter now because it's plus or minus 0. You add 0 to 20, you subtract 0 from 20, it's still 20. You do want to reduce. If you can, we can divide it by 2. We can always also divide by 4. So 4 is the biggest thing we can divide it by. 5 halves is our solution. So this one went a little bit quicker. If you were to put this on a graph, it would look something like this. At 5 halves, or 2.5, your parabola would cross the x-axis. Now this one I drew more specific because I know exactly where it crosses. It's not an irrational number, it's a 5 halves, so it's a little easier to put that on a graph. Okay, so a little bit easier. Now something else I need to point out to you is something called the discriminant. This is a good time to do it because there was a way I knew before I did a whole lot of work that this only had one solution. And the way I knew that is this part back here. This is called the discriminant. Your book is going to ask you to name that or figure out the discriminant. And all it means is it's the part inside the square root. That's all it means. So eventually, through all this work, we come to figure out that the discriminant is 0. Whoops. The discriminant here is 0. Okay, that's going to be one thing they ask you for on the homework. All right, well, what that means is we have one solution. Here's how it goes down. If your discriminant is bigger than 0, then you're going to get 2 solutions. If it's exactly equal to 0, which is the case here, you get 1 solution. And if it's negative, there's no solution. You're going to see one of those in just a second. If you go back to the example we did first, let me flash that up here real quick. Well, here's our example 1. Let me write that at the top. Here's our discriminant. We kept working it down, worked across the page. Eventually we get a single number inside that square root. Because 56 is bigger than 0, there are 2 solutions. Okay, that's how it's going to work. So that'll be part A and B on your homework. Part A is determine what the discriminant is, in this case 56, and part B, tell how many solutions you have because of that, and well, you got 2, it's greater than 0. And of course, the third part C, would be to give the solution. So looking back at example 2 here, well, that's the 5 halves. Solution, 0, root, it's all an x-intercept. That's kind of the common theme of the chapter. Solution, 0, root, it all means x-intercept. Okay. All right. This has been kind of a long video, but this will be the last one we'll do. And this is one that's a little bit different. Like I said, we had 2 solutions, 1 solution. This will be a no solution. So start out the same way. A equals, in this case, 1. Don't say 0. There is an x squared there. That means it's an understood 1. B is -4, and C is 13. Okay, so if you need to write the formula, what I would recommend is put it at the top of the page and keep referring back to it. Negative B would be +4, because a negative would be positive. Plus or minus square root of -4 squared, because it's B, and B is -4, minus 4 times A times C, all over 2 times A, which in this case is 1. All right, so I'll work this out like I did number 2. I'll do multiple steps at the same time. 4 can't change. We can't do anything to it. Now, -4 squared, that's +16. Don't let the calculator fool you. If you're having to put that in a calculator, you need to stop and think about what that means. -4 squared means -4 times itself. And the thing is, when I ask a high school student that, they'll tell me, without a calculator, it's +16. They know a negative times a negative is positive. If you just blindly punch things in your calculator, if you're not careful, it might tell you it's -16. And if you're not sure what I mean, we can go over that in class. But if you get -16 here, your whole problem's wrong, and it's a simple mistake, but it throws everything off. You got -4, the rest of this, -4 times 1 times 13, that's going to be -52. And it's all over 2. 2 times 1 is 2. All right, so 4 plus or minus square root of, let's see, 46, 36, -36, all over 2. Well, that discriminant right there, remember the part inside the square root, that's our discriminant. So it's negative, and that means that we're going to have no real solution. Okay. That means if I tried to put this thing on a graph, it just never would cross the x-axis. You'd have a parabola that would never cross the x-axis. Sorry, I thought I'd put that off the page. So it has 2 solutions, but if they're not real, then the other way to think about it is you have 2 imaginary solutions. And that probably makes not a lot of sense, but if you think back to the stuff I showed you about wavelengths and chaos theory, some of those things I touched on, this has a lot of real-world applications. It doesn't seem like it right now, but you have to get, if you get in some kind of higher-level maths and physics, you'll start to see where this actually applies to the real world. So I can't say that it's completely useless. It actually comes up a lot. All right. So I'm going to continue on with this. I just want to explain the discriminant one more time, but if you remember, we used to say this couldn't be done, and I used to make a big deal about saying no real solution. Well, that's because now we can, and we know that negative becomes an I, and square root of 36 is 6, and all that's over top of 2. All right, we're almost done. If you need to, I would recommend doing this way. You have a common 2, and that leaves you with 2 plus or minus 3i, still over 2. Because again, if you factor out that 2, you're not going to be tempted to reduce the 4 and 2, which is not the right thing. You can't reduce 4 and 2 yet. You have to take that common 2 out, and now you can reduce. And 2 plus or minus 3i, that's your answer. Again, if you need to see how it's 2 solutions, you don't have to do this step, but you can say 2 plus 3i and 2 minus 3i. That's kind of an extra step, but it's still right. That's just showing you that it has two solutions for sure. Well, let me show you some practice problems, and that'll do it for the lesson.